Let me introduce myself. My name is Anson Kokkat. I'm the product manager or offering manager in the hybrid data management division.
And I'm Adam Storm. I run the team that built the IBM Fast Data Platform and also Db2 Event Store, which we're going to be talking about today.
Okay, so I'm just going to give you a quick background. This is just our disclaimer slide. I think you've all seen this stuff before. But just some quick background. I think I'm kind of preaching to the choir here when I say, why fast data is important and why we're kind of investing in this from an IBM side, right? So we have a Forrester report that just recently got published. I encourage you to go have a look at this report. It's at ibm.biz/Forrester Fast Data Paper, and the link is at the last slide there. But have a look at this. I mean, really, if you look at this report, we polled about 200 different professionals and people in different fields, and we asked them, why fast data is important, right? And you can see some really good results out of that, some statistics showing you how people responded, but you are getting statistics of things like 80% of people want to do stuff with fast data, but don't really know what to do or need some direction or need some guidance on that. So you'll see what they're trying to do with data coming in from mobile and IoT. So all this data coming in from all over the place, and the Forrester report that we have out there also says that the data that's coming in, the value on acting on it in real time is tremendous, right? It's a different way of thinking for a lot of people, and just how to be able to handle that is stuff that we need to start worrying about and stuff that we need to be dealing with in our day-to-day lives. So what do people do today? I mean, you just have so much choice out there today, right? There's just all these open source components that are out there that you can pick and that you can use. But a lot of people, like I said, don't know where do they actually start, what components should they pick, what are the right components that they should be using, how do they integrate the components that they pick together, how do they make them work together so that they're operational. And then even when they go into production, you have to worry about stuff like, all right, I'm in production now. If something goes wrong with one of these open source components, who do I call, right? How do I get support for that? So these are all the challenges that people have to go through when they're dealing with open source components. Just a note on the IBM side as well. I mean, a lot of people don't equate IBM and open source together, but actually we've been doing open source for quite a bit. And for all the same reasons that you folks use open source as well, right? You have a whole community of folks that are working on open source that can deliver things much faster. It's a community that's also delivering on a common cause, and a lot more flexibility, right, in terms of the components that you get to use. So actually IBM in the Apache, in the data and analytics space, is actually one of the top contributors to the Apache Foundation. Like I said before, a lot of people don't equate IBM with open source, but over the past, I would say, many years or so, we have been doing a lot in the open source space. Just some history between Lightbend and IBM. I mean, why we picked IBM or Lightbend as a partner. It does go back a couple of years now, but really what we have been doing is, Lightbend's strong commitment to the open source community and all the work that they've been doing is kind of a good fit with what we're trying to do with IBM. So it started back in 2017. I mean, we did announce our collaboration with Lightbend back at that time. Shortly after that, we came out with the Reactive platform. So that's an offering that we have that we sell via IBM. And then we have, just recently, we have the IBM Fast Data Platform that's available as well. I'll go through this at the end just to show you pricing and packaging wise, but this is a strong partnership that we've built over the years with Lightbend, and a lot of good synergy between what they're doing from an open source project and all the components that they have, combining that with what enterprises are trying to do with majority of the customers that we deal with on a day-to-day basis.
Okay, so one of the reasons why we at IBM, and I think the folks at Lightbend as well, think that there's a natural synergy between our two companies is because we have the components with which you can solve fast data problems. So before we get into that solution, what does it take to solve a fast data problem? The first piece, obviously, is you need to be able to develop applications that can solve fast data problems. And to that point, you need a reactive toolkit that you can use to develop these fast applications, applications that will scale, that are designed in microservices, et cetera, et cetera. But then once you have that developer framework, the other components that you need are a back-end store that's fast, that's always available and reliable. And then you need some way to derive insights out of the data that you're pushing into the system. And as we heard from the keynote this morning, it's important to be able to derive fast analytics and deep analytics on the data that you're bringing in. And finally, it's best, as Anson mentioned, if you can tie this all together in one cohesive stack. So what we're bringing with the IBM Fast Data Platform is that complete stack. So on the reactive side, we have Akka, Lagom, and Play, the core components of the reactive platform. And then we're pairing that with a data store that's always fast and reliably available, and that's Db2 Event Store, which we're going to talk a little bit about in more depth later on in the talk. And then Watson Studio, which is our platform for machine learning and AI, and we tie that all together into what we call the IBM Fast Data Platform. Okay, but before we get to the Fast Data Platform and why we need it, I have a question. Just 1 second. Sure. How many people in here know about the Lambda architecture? Know what the Lambda architecture is? Okay, and how many people are using the Lambda architecture? Okay, so a bunch know about it, and a fair bit less are using it. For those that don't know about it, I'm going to explain it. Try to explain it on a single slide. So the Lambda architecture you can read about online, but at a high level, what it is a way of bringing in data so that you can analyze it both quickly and then derive analytics from the same data. And the way this problem is typically solved in the Lambda architecture is the data streams in to two endpoints. The first endpoint lands the data very quickly, but isn't very good at querying data, or you can't query it in a deep way effectively. The second layer, which is called the batch layer, allows you to query data very efficiently, but it can't ingest data very quickly. So you have this dual problem where either you choose to have the data ingested quickly and available, or you have a lag and you can query it very efficiently. So this architecture has taken the world by storm for the last number of years, and principally it's because you can stitch it together using open source components very cheaply and easily. But there are some problems which exist in the Lambda architecture, which a bunch of people have been trying to address more recently. So let me just talk about a few of them. The first is that it's complex. You have two separate architectures that you need to maintain. Either you have a Hadoop ecosystem and a Cassandra ecosystem, or you're writing directly to S3 and you have Kafka as your speed layer. But the point is that you have to manage the architecture of two separate layers. The second is it's costly. Because you're running two architectures, you have to store two copies of the data, which can be expensive if you're running with large amounts of data. And finally, your queries have to be able to intelligently manage these two layers. You can build a serving layer in between to try to keep that from the queries, but still, there's this complexity in managing this Lambda architecture. So what do we think is the solution? Well, maybe Anson can take over here and talk a little bit about the Fast Data Platform architecture.
Yes, I mean, really what we've done is we've combined our IBM components and along with the Lightbend components, and we've come up with something called the IBM Fast Data Platform. So if you're familiar probably with the Lightbend Fast Data Platform, so all the microservices capability along with the data plane, as well as their added services through the monitoring and management console are there. But if you need a database underneath that can handle all of that streaming coming in, then we have Db2 Event Store as the database, and then we have Watson Studio available for the data scientists, for the machine learning, for the AI capabilities. So you're getting basically a complete stack. We combined a bunch of components together, a bunch of open source components, as well as our own IBM and Lightbend components together, and we're giving you all that in a complete stack, and that's what we call the IBM Fast Data Platform. I'm just going to give just a brief use case, a couple of use cases just so you understand. You probably saw this in the keynote already if you were there. we have this satellite company that we're working with, and they have just, tons of data coming in from all the sensors. You can imagine a satellite out in space and all the information that you have to keep track of. Each one of these satellites costs about $400 million, right? So if something goes wrong with that, you can imagine, the amount of money that a company would lose if they had to lose one of these satellites or something were to go wrong with one of these satellites. So what do they do today? Just to give you a more clear or a more detailed look into what these guys are using underneath the covers. I mean, today they have traditional databases and traditional analytics that they use where they get basically a lot of false alarms. They're getting stuff like, they have just too many parameters that they track, and it has to fall within that threshold in order for them to understand if something is going wrong with these satellites. So we worked with them, or we are working with them right now, to build out a more real-time fast data solution, right? Where they can track these sensors, but be able to do stuff like machine learning on the data that's coming in real time, right? Rather than waiting for after the fact. As well, because of the amount of data that's coming in, they can handle a lot more of that information that's coming in. They can handle that information with one database rather than multiple different databases that are out there. So we used IBM Streams and Db2 Event Store underneath the covers for basically putting the solution together. Just a couple of more use cases. Credit card fraud detection. I think everybody's looking for a solution, especially banks and these large finance companies that are out there. They're looking for, how do I solve this problem today? I mean, these are the typical use cases where you would want to deal with fast data and be able to have some type of solution that can deal with that. Capacity management, just being able to monitor and track network data that's coming in, right? And to be able to optimally use that data, the network data that's coming in, be able to look for anomalies and detect when things are going to go wrong. That can save a lot in manufacturing. It can save a lot in if you're dealing with any type of industrial type of use case where you have tons of sensors that you need to monitor that data and keep track of all that. And predictive maintenance as well, right? So let's say I do have a manufacturing line. I'm keeping track of all those sensors, and I want to be able to say, I know that one part of that line is going to go down. It's reached its capacity or 70%. Rather than taking the whole line down, it's nice to be able to say, I know that this part of the line is going to go down. Let me go and take care of that part alone, right? So many different use cases around IoT and fast data. A lot of different industries where they can take advantage of these different capabilities that we have. Okay, so now that we've motivated, hopefully, the use case for all of this fast data that we've been spending a lot of this week on, I want to talk a little bit more in depth on what the fast data platform delivers. I think that most of the people in this room have a good understanding of what it delivers on the Lightbend side. So we wanted to dive a little bit deeper into the two components that you probably aren't as familiar with, one of which is Db2 Event Store. So if you have been developing applications that need a back-end store in the last 10 years, you probably know that everyone and their dog has a database these days. Every company has multiple databases. There are actually databases that are named after dogs. It's a whole big thing. So why does the world need a new data store? Well, we think that the value proposition that Db2 Event Store delivers is pretty unique and is well suited for fast data. So there's a few attributes that it delivers. The first is you can bring in data to it extremely quickly. It can ingest more than 1 million inserts per second per node, which on a 3-node cluster works out to about 250 billion events per day. The ingest rate scales linearly as you add additional nodes, so you can scale it right out. And one key point is that the data is ingested very quickly, making it available to queries, but then in the background, it's refining the data and enriching it so that it's more analytics friendly. And I'm going to talk about that in a little bit more depth. The second is that it opens your data up to real-time analytics. So the second you ingest the data, even though there's some data enrichment going on in the background, the data is available for queries. So you can get to real-time analytics on all of the ingested data that you're looking for. And there's some technology that we've built into it that allows both super fast lookups, but also deep intelligence scans for the types of queries that you would want to run around machine learning and AI, but also SQL queries that you want to do a full table scan, join tables, and so on. The other thing is it writes all of its data into an open data format, Apache Parquet,
And we think that that's advantageous for a number of reasons. First of all, Parquet is pretty much the standard for analytics-friendly data formats. But also, there's no vendor lock-in. You want to take your data after and move it to another store. You want to query it using existing Parquet-compatible tooling like Spark or Impala or whatever. You're able to access the data directly where it lives. And most importantly, there's a single copy of the data. So unlike in the Lambda architecture where you're managing 2 components and 2 copies of the data, this system abstracts you away from all of that by providing fast insert and then also this real-time analytics on the data in the background. And finally, it's built for high availability. If you run it in a clustered configuration, it replicates all the data, stays up in the presence of failures, and it's architected to scale to quite large clusters. So this is what the system looks like in practice. There's a bunch of open source connectors that we have where you can feed your data in, including using Kafka and our streaming product, IBM Streams. The data comes in and we quickly persist it down to this shared storage layer, which is flexibly configured. You can use either Gluster file system, you can write directly to Amazon S3, you can write to IBM's cloud storage as well. And then the data is stored in this storage layer in an analytics-friendly fashion such that when queries arrive to the Event Store engine, we can service them very quickly. Now, because the data is all written in Apache Parquet, you can also query it directly using Watson Studio or Apache Spark. But the Event Store system also comes with Watson Studio built in. So you can run your notebooks and machine learning and all of that right on the data where it lives. And I actually have a demo of that coming up in a bit. But since we're all developers here, I'm sure you're curious as to how it ingests the data very quickly. So I threw this slide in which talks about how it works at the nuts and bolts level. So this process just talks about how the lifetime of an inserted batch. So the batch comes in at the top, arrives at the node that it's been sharded to, and then we quickly write that data to the logs, which are kept in memory, and then we flush the logs to local fast storage so that it's persistent. If anything, if the node goes down and comes back up, then we still have the data. But writing it to a single node isn't good enough because that node could catch fire and be gone forever. So in step 4, we replicate to 2 other nodes, so we have some durability there. Once we get the acknowledgement back from those nodes, then the insert is part of the database and is queryable. So the main idea behind this is to do everything on the persistent side as quickly as possible, and then defer everything else out into the end. And so the rest of the insert processing is in step 6. And what goes on in there is we ensure there's exactly once delivery, which is important if you're streaming in data and you have duplicates. Also, as part of that, we build an index on all of the data so you can quickly query data using that index. We compress the data and write it to the Parquet file format. And then we also generate what we call synopsis data. This is data which allows you to determine which portions of the database contain which sets of values. And it can be used to speed up queries by orders of magnitude over systems that don't have this kind of metadata. And finally, we write this long-term, we write the Parquet files and the synopsis data and the index to long-term storage, either object storage or Gluster file system. And the reason we do all of this in the background, obviously, is 1, it's expensive, but 2, if you're deploying this in a cloud environment, especially, writing to cloud object storage or S3 is very expensive and high latency. So we want to be able to batch up as many inserted rows as possible before we undertake that task to write to storage. Okay, the other thing I wanted to talk about is how the Event Store system differs from traditional big data systems, which also write Parquet, because writing the Parquet data format is not novel. But we have some attributes to the system which we think are novel, at least around Parquet. And those two attributes are the synopsis that we're generating and the immutable index that we're writing. So the index really allows us to service point queries very, very quickly. Point queries meaning you want to know which key, which values are associated with which key. And the synopsis, as I mentioned in the previous slide, allows us to really ignore huge portions of the data if it's not relevant to the given query. And you can imagine if you're inserting data by time series, or if you're inserting data, say, in increasing order, knowing which portions of the database contain the time series values that you're looking for, or the key values that you're looking for, can save you a huge pile of time. So that you don't have to scan all of the data, it directs you to exactly where you need to go. Okay, so then I'm going to hand it off to Anson. He's going to talk a little bit about IBM Watson Studio, which is also in the Fast Data platform.
Yeah, so you might have heard this morning in the keynote about being able to deal with AI and machine learning models, right? So Watson Studio is a tool to help you with all of that. So we include a bunch of open source components, so things like Python and R, Scala, Jupyter Notebooks. We have RStudio IDE and Shiny in there. Apache Spark, and you can even add all of your favorite libraries in there. We have a bunch of stuff built around community as well. So there's a bunch of articles and tutorials and a bunch of resources for people that are starting with machine learning models and want to be able to work on this on their own. There's a huge community around there that can help you with this as well. And then we have our IBM value add services on top of that. Stuff like SPSS Modeler, if you want to do visual model building. We have decision optimization. If you have different projects that you're trying to do, we have version control over those different projects. It helps you deploy and deal with model management, right? So it's a complete set of tooling that you would have for data scientists, rather than people going in, downloading each one of these different components. If you're a data scientist and you want to kind of have one tool set that has everything in the box, then you would look at something like Watson Studio. And just a quick point here. I mean, our customers love this stuff. If you look out at what they've been doing with some of the Watson Studio stuff that's out there, I mean, they're really happy with getting a complete tool set that kind of brings their data scientists and their data scientist teams together, right? I think in the past, people would go and kind of download individual products and kind of have different ways of doing data science capabilities, but our customers are really seeing the value in being able to deploy this, across an enterprise, across a group of data scientists, having them being able to collaborate and build and deploy in a common way, all that makes sense for our customers as well. Okay, so this is all sort of theoretical, but I wanted to walk through a couple of demos which show the platform in action. The first demo is about Fast Data Platform using the Killer Weather application. How many of you know the Killer Weather application? Okay, there's a few, good. So the Killer Weather application is an application which is designed to showcase the Fast Data Platform. It's been used at Lightbend for a number of years. The idea behind it is you have a bunch of data that's coming in from weather stations, and it's flowing through the system, and the goal is to run a predictive model on the weather data, to take the weather data and predict what the weather is going to be some number of months or years from now. So the idea is that the weather station data is flowing in through Akka Streams, which then feeds it into Kafka, and then into the Killer Weather application. Now, there's some massaging of the data going on there, and then we're feeding it into the Db2 Event Store. Now, Event Store is both landing the data, but then also serving Watson Studio, which is doing the machine learning, generating the machine learning model, and then serving that machine learning model so that it can be queued up on a Kafka queue, and we can then start scoring that machine learning model against the Kafka weather data that's coming in. And that's really where the prediction is going to start happening. And then finally, once the prediction is generated, then we're feeding it back, the predicted data back into Event Store, and we're serving the predicted data using a Grafana interface. So I'm going to walk through what this looks like in practice. Hopefully this starts playing. So this is what the Fast Data Platform dashboard looks like. You can see the various components to it.
Then if you drill deeper, you can see here, this is a 10-node cluster. And if you move around at the top, it shows you which components are running on which of the 10 nodes. And also if you scroll down onto the bottom, it'll show you which components from the list are running where in the cluster. Okay, so that's the Fast Data Platform UI. And then here we're going to walk through this is the Event Store UI, which is going to show the weather data coming in. You can see the data streaming in on the top left-hand side, in that circle on the left-hand side, through the 3 nodes of the cluster, and then we're writing it to shared storage, as I mentioned, in this asynchronous mode. So you can see the data's pouring in at several million inserts per second, and then we're pushing it out to shared storage in batch as it's coming in. And then I'm going to show a little bit about the notebook. So this is the notebook here, which generates the fast data platform data. So there's a machine learning model contained here. And one of the things that we've done for this conference is we've put all of this in Git repo, and I have a link to it in a couple of slides, which allows you to regenerate this whole fast data platform environment on your own laptop using Event Store and the Killer Weather application. But finally, once the machine learning model is generated and deployed, we can see how it looks in Grafana. So this is Grafana mapping the machine learning model predictions as they're coming out. And you can see the main chart to look at is the one in the middle. And in the middle, what's going on there is we're showing the actual weather data now, as well as the predictions that we made based on the model that we generated. And you can see the green line is the actual weather data, and the blue line is the prediction. So it's a pretty decent model to predict this weather data. Now, showing videos is one thing. Let me get a little bit more ambitious and pop out of here and then show you some live stuff running on my laptop. Okay, so this is the Db2 Event Store Developer Edition, which you can download today and run it on your laptop. I have this notebook running here, and the installer lays down Event Store as well as the UI and a local version of Watson Studio. But if you run through this, how many people have used notebooks before? Okay, so like around half. So if you run through this notebook, it's just going to, it's already done most of this stuff. It's going to create a bunch of, let me talk about this section first, and then I'll scroll up a little bit. So here we're inserting data into the Event Store database, and you can see that even on my laptop here, I'm able to get, with one stream, 95-ish thousand inserts per second. If you scale this up to multiple streams, you can get to like 200,000-300,000 on a laptop, which is, I think, pretty decent performance. But this notebook, what it's doing is it's defining the database in the Event Store repository, and then it's opening the database, creating a table, and then generating random data, and then inserting it into the Event Store repository, and then down here just running a couple of simple queries. So if you download and install this Event Store on your laptop, it comes with, just one second, it comes with a couple of example notebooks, and you can code your own. But then one of the other things I wanted to show is this is all running on my laptop, so I can show you that if we, just give me 1 second. I don't know if you're going to be able to see this down at the back, but we can see that there's a bunch of Docker containers that are running on my laptop, and I can just exec into one of them. And then in here, we can just do a find, and it'll show that the Parquet files have been generated in the background after we did that insert. So it's a good way to generate Parquet data if you need it for nothing else than that. Okay, and then I also wanted to talk a little bit about the GitHub data or repo that we've created just for this event. So here, as I mentioned, are the notebooks for both the prediction and the weather analysis. You can click on here and Git actually brings it up pretty nicely if the network works. Yeah, so this shows you the whole notebook of how to generate the machine learning model on the weather data. And then if I pop back out here, in the main repo, there's all the instructions on how to load and install the data, generate all of this data and have it running up through the Grafana interface here at the bottom. Okay, here's the link. I'll leave this up here for a couple of seconds. Here's the link to that Git repo if you're interested in it. If you want me to write it down for you afterwards, I'm happy to do that as well. And while you're writing this down or taking a picture, if you're interested, I'll let Anson talk a little bit about how things are packaged.
Yeah. So I think Adam mentioned already, right, there is a developer edition that's available. So I encourage everybody to go download that developer edition. It's free to download. You can, you download it on your Mac or Windows or desktop machine. And you get pretty decent insert performance with that desktop edition, right? You can get, Adam showed you you're getting about 95,000 inserts per second. If you do a little bit more, you can get close to 200,000 or so inserts per second. So developer edition, have a look at that. Go to ibm.biz/event store. Play around with some of the notebooks that are in there, the sample notebooks, get familiar with it. And if you need the enterprise grade version, you want to put this into production, you need the 3 million inserts per second per node, 3 million inserts per second on a 3-node system, and you want to put this into production for a very heavy-duty type application. We do have our enterprise edition available. It comes in a 1-node and a 3-node flavor today. All this is packaged with Watson Studio and has basically all of the stuff you need. It's all Docker and Kubernetes based, so an easy install. You can put it wherever you want. I encourage you to go download these 2 things and play around with it if you're interested. And then, I mentioned before the fast data platform. At IBM, we do have something called the IBM Fast Data Platform. So that is a combination of the Lightbend Fast Data Platform plus the Db2 Event Store, and then you're getting Watson Studio as well in the package, right? So you have all of these 3 capabilities in one package. So that thing is called IBM Fast Data Platform if you're interested. I'm just going to put up some of the main things if you want to have a look at this. So the ibm.biz/fastdata is the website you would go to if you want to download some of our stuff. We have a nice video up there, the Killer Weather app demo that Adam just showed. If you want to see the full video of that, it's up on YouTube. You can get it from that main website there. That Forrester report, it should be up there or will be up there very shortly, where I talked about if you need to convince somebody in management why this stuff is important. I mean, look at this Forrester report. You'll get tons of good data on why fast data is important. And then our names and email addresses are here as well if you guys have any questions. So we work very closely with the Lightbend team. If you need us to do a deeper demo with you guys or somebody in your company to kind of help you convince or to see if there's possibilities that you want to use this stuff, get in contact with one of us and we'll help you out. Thank you.